This is another stoichiometry question involving limiting reagents, excess reagents, and theoretical yields. 10.0 grams of iron 2 nitrate was reacted with 3.05 grams of aluminum. Which reagent is limiting and which reagent is in excess? How many grams of excess is present after the reaction is completed? And how many mole and grams of products are produced theoretically? To answer this question, first make sure the chemical equation is balanced with correct stoichiometric coefficients. In tabular format, this helps keep track of the many numbers and units. Enter the data that is given. Enter the mass of the reactants, iron 2 nitrate, and aluminum. Enter their molar masses that you can determine using the periodic table. Calculate the mole available for each reagent using the unit analysis method. In the unit analysis method, the mole of the substance is equal to the mass times 1 over the molar mass. And the table shows the mass is on top of the molar mass, so take the mass divided by the molar mass. To determine the limiting reagent, compare the stoichiometric mole ratio with the calculated mole ratio. Choosing iron 2 nitrate as a numerator means that you are testing to determine whether this is the limiting reagent. The stoichiometric ratio of iron 2 nitrate over aluminum is 3:2 or 1.5. This ratio is larger than the available mole ratio of 0.0556 divided by 0.113 or 0.49. This means that there is not enough iron 2 nitrate to react with all the aluminum. Iron 2 nitrate is the limiting reagent. It must be used up. Enter the number of mole required. The leftover must be 0. Now calculate the amount of aluminum needed to react with all the iron 2 nitrate. Then enter the data in the mole required for aluminum. The difference between the mole available and the mole required for aluminum gives the excess mole. This must be a positive number. If it is negative, then we have the wrong limiting reagent. To calculate the excess gram, multiply the excess mole with the molar mass grams per mole for aluminum, which is 27 grams per mole. Now, to determine the theoretical yields, which are limited by the iron 2 nitrate of 0.0556 moles, set the table up with the appropriate heading. Enter the data that can be easily determined first. The molar mass can be determined, and remember, the molar mass is gram in 1 mole. Do not factor in the stoichiometric ratio because this will be determined later. The theoretical mole formed on 100% conversion of the limiting reagent iron 2 nitrate can be determined using the unit analysis, and the conversion factor is the stoichiometric ratio. To calculate the mole of iron formed, multiply the mole of the limiting reagent, iron 2 nitrate, with the conversion factor ratio of 3 mole of iron to 3 mole of iron 2 nitrate. Enter the data in the table. The theoretical yield of gram of iron is calculated by multiplying the mole of iron with the molar mass of iron. Similarly, the theoretical yield of aluminum nitrate is determined by the unit analysis calculation. This time, the stoichiometric ratio of aluminum nitrate to iron 2 nitrate is 2:3. Remember that the denominator must cancel with the unit that is being converted. Enter the data for the mole of aluminum nitrate and then the gram of aluminum nitrate. And this is how you would successfully determine these amounts using my tabular